Welcome to myproject.bazaar.com. Our project title is DC fast charging station for electric vehicles. Our project abstract is the main of concept electric vehicle charge fast charging techniques. This is a DC to DC fast charging technique using the battery concept. The battery based on the lithium-ion battery used. So the main objective of this article is the various of the fast charging techniques that being used to charge the lithium-ion batteries in electric vehicles. The various charging protocols is constant current, constant voltage, current, constant voltages, multi-stages, constant current, bearing the current method. So the pulse charging method, everything is a fundamental concept of modeling and simulation we are designed. So the first we have the charging time and discharging time, and then how much of the battery lifetime that also will be calculated. So the fast charging we have implemented MATLAB following process. So the critical comparisons among the various charging method about the possible future research direction in the design of development of the two fast charging techniques have proposed based on the demands. Project flow diagram. First of all, the PV panel has a input. PV panel based on the solar PV panel. So this is a two input. One is the irradiation level, another one is the temperature level. So the irradiation level maximum for the 1000. So temperature level 25 degree maximum. So the PV panel has the input based on the two conditions. After that, using the fuzzy MPPT. So the fuzzy MPPT based on the pulse generation. So the pulse generation we have using the MPPT method. MPPT method based on the maximum power point tracking. So that using the fuzzy method we generate the pulse. So which switch will be on, which switch will be off. The T1 will be on, the T2 will be off. This is the condition we are the pulse generation. The 0 is the off and 1 is the on. This is the pulse form using the MPPT method. After that, using the DC to DC boost converter. The PV panel wise the voltage will be reduced. We are boosting that the electric vehicle charging, fast charging. So using the boost DC to DC converter. So after that, using the two method. One is a capacitor storage, another one is a battery storage. This two storage based on the bidirectional to the DC to DC formation. After that, connecting to the BLDC motor. BLDC motor based on the electric vehicle concept. So this is the storage of two hybrid source. One is the capacitor base, another one is a battery base. So we are generate to the voltage and then current. The calculate the power. So the V into I equal to P. So P based on the power. So the power will be calculation for the using the battery and then super capacitor. After the connected to the BLDC motor. The BLDC motor, the torque will be set after the regeneration of the how much is the electric vehicle charging, how much will be electric vehicle discharging. So how much the electric vehicle charging, how much will be electric how much will the electric vehicle charging and how much will the electric vehicle discharging. So this concept. So there's a capacitor and then battery based on the how much current will be generated, how much current will be produced. So that is a in between the bidirectional connection form. Overall circuit. First we are connecting to the supercapacitor and then battery. After that, connecting to the inverter. So the inverter based on the DC to AC conversion. In between the connect to the DC to DC boost converter. After that, there is a pulse generation. We are using the S1, S2, S3, S4, S5, S6 switches. We are using the inverter model. So three phases after connecting to the BLDC motor. So this is a permanent magnet synchronous motor. So first execute the process. So we are using the MATLAB 2018B. The simulation time we are set 0.02. So this is a super capacitor, this is a battery. this is the output of so this is a T1, S1, S2, S3, S4, S5, S6. This switches will be off, this switches will be on, this switches will be on, switches will be off. This is the process. So this is a pulse generation. So this is a 3-phase waveform. This is a torque measurement.